So let's take a gander at example 2. Now we have a function already given to us, right here, excuse me, we have the graph already given to us, so we're going to interpret this. All right, a pendulum swings back and forth in a vacuum. Why in a vacuum? Because no wind resistance, so it doesn't slow down necessarily from the wind. Its distance from an object is captured using a motion detector for the object. The setup is pictured below at the right. So here it swings back and forth, and it tells how far away from this object it is. So clearly it goes farther away, closer, farther, closer, farther, closer. The other way around. Yes, that's right. Write an equation for the distance from the pendulum to the object as a function of time. Okay, so what pieces of information we need? We need amplitude, we need period, we need phase shift, vertical shift. We're going to plug that information to here. And since it asks me to write it as a function of time, ultimately my goal is, we're going to use capital D here. So it's going to be something like d of t is equal to. So we're going to use in that form. So we're going to have to convert it to function form. So let's see how to approach this. Let's start with period. It doesn't matter if you go from high to high or from low to low. In this case, let's go here. So this is 1.5. And this one here is 3.5. So the period is 3.5 minus 1.5, which is exactly 2. Now, what does the period help me find? Remember, the period helps me find the letter A. This is not A, but it helps me find the letter A. So I know that 2 is equal to 2 pi A. Now, when I solve for A, I get 2 pi over, let's try that again, bloop, 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 bloop. 2 over 2 pi. To get approximately.
Why can't you just cancel out the 2 instead?
Oh, you can. Yeah, sorry. You could simply reduce like that, and then it's the reciprocal of pi. So when we look at amplitude, amplitude is going to be half the distance from the highest point to the lowest point. So here we see that if we look at this, it's 1 to 1.5. So that means my amplitude can be calculated like this. 1.5 minus 1 divided by 2. So 0.25. We already can start substituting in. I can substitute this value here into A. And it turns out that my amplitude here is my B. So the 0.25 can be substituted into the B. All right, vertical shift. Vertical shift. The key thing on vertical shift is to look for the midline, because that just tells you how things shift up in sine. So the parent function for sine starts effectively there. That's where the x-intercept is and the y-intercept at the origin. So all we see is that it shifts up to exactly right there, this being my new midline, which is 1.25. So my vertical shift is 1.25. Now we vertical shift up, so we see how that has to translate when we substitute in. Since this is the sine function, we know my parent function effectively starts at the origin, then goes up and down, up and down. Well, this one here starts right there and goes up to its max here, min there. So it has no phase shift. It has no phase shift. It does not shift left or right based on the sine function. If it were a cosine function, yes, it would. All right, so now let's begin to substitute things in, and then we're going to solve for, in our case, the y, but we'll change that to a d. Okay, so d for distance minus my k, which we know how much it goes up, is 1.25. And we know that B is 0.25 here.
Why would it be D?
All right. Sine now. And then I'm going to say T for time minus my H, which is 0. I don't need to write it. And then A being 0.3183. And now to finish up, what I need to do is multiply by 0.25 or on both sides, which is the same as dividing by 4. So I could say 1/4 over here. So multiplying by 0.25, multiplying by 0.25, which is the same as multiplying by 1/4. And then my second step is I have to add 1.25 here. So this is ultimately what my answer is going to look like, is 1/4 sine T over 0.3183. And now I add the 1.25 there.
Oh, hi, Mark.
On example number 3 here, we have a sine wave for the average temperature T of Yuma, Arizona. And we're going to use this graph. So my numbers are going to be based off the graph because that was the skill we just did previously. Obviously, I can plug all this stuff straight into my calculator, and the calculator can find it for me. So first thing here is, according to this looks to be the lowest. This looks to be the highest. So I can find the amplitude by subtracting 107.9 FM from 69.9, subtracting, and then dividing by 2. So on this we got 19. If you got a different number, that's probably because you used this 69, which actually is slightly better. But I'm just going to go by hand here to do that. Okay, so that means the amplitude is plus or minus 19 degrees Fahrenheit from the average, which is somewhere here. Next, what's the period? The period is less complicated than you think. The lowest point is here. The lowest point is here, which is a 12-month gap. So 12 months is my period. And, of course, this helps me to find out what A is. And we can leave it in terms of pi if you want, because that's an exact answer. Or we can go decimal. If we leave it in terms of pi, we get 6 over pi. And that's it. Simply 6 over pi for A. Or we can approximate it there. Again, what does this mean? The period is, or the A is 1.91. That means we effectively multiply the 2 pi by this in order to get my new period. Okay, vertical shift. Vertical shift, the best way to do that, and using my graph numbers, not the other one, is to find the average of the high and the low. The average of the high and the low. So what does this say? If I get 88.9, that means the average temperature is roughly 89 degrees, give or take 19 degrees throughout the year. Throughout the year being the period. Now the phase shift. Phase shift is horizontal. Now cosine starts high over here, but it's high over this way. So how many months? 1, 2, 3, 4, 5, 6. It shifts all the way 7. So the phase shift is 7 months. So now plugging in, at least to start with, I'm going to use T for temperature. So T minus my K. All right, now when we finish up, to get T is equal to 19 times the cosine of x minus 7 divided by 1.91. And then all adding 88.9 degrees Fahrenheit. And I think my x should actually be a different letter, t for time. So t minus 7. There. All right, the last problem we're going to look at is, now we start with a function, and I do apologize, the function here is incorrect. So this right here should be a minus. I mean a plus. I know. All right, so here's how an oven works. Because an oven is not 100% precise. What it does is it has a temperature and a tolerance. So when an oven is set to a particular temperature, the heat level rises and falls. So it actually fluctuates slightly above and below the level that you set it, at which you set it. So assuming that when a particular oven is set to 425, the oven temperature T in degrees Fahrenheit and minutes after the burner first shuts off satisfies this function. So what does it actually mean? Let's interpret it. Let's interpret. This is the setting, which means the average. This here, the 6, because remember, cosine can become 0, right? Or, so it can be positive 1 or negative 1. So ultimately, we can get to positive 6 and negative 6. So it's like saying this, 425 plus or minus 6 degrees. Or slightly, or very close to 6 degrees. So, that means we now have the average. The amplitude is 6, so we know it's going to get above that or below that. So what's my max? My max is 425 plus 6, which means it could get as high as 431 degrees Fahrenheit. The minimum is going to be 425 minus 6. So 419 degrees Fahrenheit. Notice that 12-degree gap, the 12-degree gap hopefully is not always the case, because 12 degrees could be dramatically mess up your popovers if you're making, and they don't pop over. All right, next we want to calculate what the period of the sine wave is. So remember, the period is based on this over here. So let me just refresh what needs to happen. If I have this, I don't know exactly what the period is until it's written in the format that looks like this, right? So M over my B. So how do I write it like so? Well, cosine now can be written as M over, instead of saying 0.9, we can say that as 9/10. So when I do reciprocal to get down below, I get like so. Now, of course, this hasn't found me the period, because remember what the period is. The period is 2 pi times A. So 2 pi times 10 divided by 9. So the exact period is 20 pi over 9, but now we can approximate that value. 7.
Is that 10 over A or 10 over 9?
10 over 9. 7 what? That's the key thing on this one here, is the period is being measured by minutes. So every 7 minutes, it's going to fluctuate between the high and the low. It wants to average out to be at 425, but it's going to start a little bit higher. Then the oven shuts off. The heat gets released a little bit, and the moment the sensor hits 419, it kicks it back on for a few minutes. until it gets to 431 again, and then it drops back down and back up again.